Okay, so we've got a rotating, basically it's like a galvanometer, right? But they're showing you this rotating square, basically. We're to believe that this is square, even though it clearly looks not square. It's rotating in a magnetic field, and we've got all these, there's actually 80 turns on the coil, and even though there's not, but anyway. Okay, so the ends of the coil are connected to slip rings, and the plane of the coil, and the magnetic field is entirely uniform in there too. Okay, so explain with reference to the diagram how the rotation of the generator produces electromotive force between the brushes. If I had to explain this, they didn't list this in the mark scheme, but remember that what EMF is minus N d flux dt, right? Well, flux is BA cos theta, right? Well, theta is changing, right? So if theta changes, then the flux changes, right? That's what's going on there. But I think what you need to talk about is flux, right? The flux linkage. Linkage means that the magnetic field lines go through the coil, the face of the coil, right? Well, right now in this position, none of those lines go through the face. In a 90 degrees later, though, all of that is going to go through. So that the area is going to change, that the magnetic field impinges upon is going to change, right? And that changing flux induces an EMF because of Faraday's law. Okay. Do use the word induced when you talk about EMF. You need to say induced EMF. But anyway, another way to explain it too is that these charged particles in that wire are being moved through a magnetic field, and there's going to be a force acting on them because of that. They don't allow that in the mark scheme, but there's lots of ways to explain this. Okay, but really what's going on is that the flux is changing over time. All right, so let's look at the computation part of this, right? Calculate for the position in the diagram the magnitude of the instantaneous EMF generated by a single wire between A and B, right? Well, what they're looking for is use B, that the EMF is B times L times V, right? And they give you the velocity, they give you the length of it, they give you the magnetic field, right? And it's small, it's less than a tenth of a volt, okay? And then they say, hence calculate the total instantaneous peak EMF between the brushes, right? And it's actually occurring at the instant that you see it in that picture, right? And that's going to be, I think that, what is it? The number of windings is 80, right? But keep in mind that there's a part here that's going to have an EMF induced and a part here that's going to have an EMF induced. And any EMF induced, by the way, on these parts cancels each other. It's these end parts that are the money, okay? So you're going to have an EMF induced on both of those parts, right? And so if there's 80 turns, that means that there's 160 of those EMFs added up in series, okay? So basically whatever your answer is here, it's going to be 160 of those, okay? For some reason, I wrote down 160, but I think I only multiplied by 80. Which really made me sad. Actually, I wrote the windings down as being 40. I don't know why, and then I actually got that one wrong because I used 40 instead of 80. But anyway, yeah, good luck with that.